0 plus 1 is 1, square root of 1 is 1. 3 plus 1 is 4, square root of 4 is 2. And 8 plus 1 is 9, square root of 9 is 3. Okay, so again, with square root graphs, it goes forever in a single direction, but not in the other. All right, so just one arrow. Okay, and then we'll also graph g of x, which is 2x plus 1. Okay, so we're still trying to end up at the same perfect squares, but these numbers are a little trickier, so I might need to write them out. Okay, so I set the radicand equal to the first perfect square of 0. To solve for x, I would first subtract 1 from both sides, and then divide both sides by 2. Yep, so first good x value would be -1/2. And yeah, when you plug it in, this simplifies to 0, so square root of 0 is 0. Okay, next perfect square is 1. So in order to end at 1, 2x would have to equal 0, which means that x itself would have to be 0. Okay, so then when you plug 0 in, 2 times 0 is 0, plus 1 is 1, square root of that is 1. Okay, so 0, 1. Next, we want to end up at 4. Okay, so how can 2x plus 1 end up at 4? If x were 3 over 2 or 1.5. Okay, so when you plug in 3 over 2, 3 over 2 times 2 is 3, plus 1 is 4, square rooted is 2. Okay, so 1.5 comma 2. Okay, and then how do we end up at 9? Okay, so if x were 4. Okay, so when you plug in 4, 2 times 4 is 8, plus 1 is 9, square root of 9 is 3. So 4 comma 3. Okay, so that one would look like this. Okay, and then the last question is, where does f of x equal g of x? Oh, sorry, let's finish this one. Okay, so looking at the two graphs, how do we know where the two functions are equal? You look for the intersection, right? The intersection is a point on both graphs. Correct. Uh, yes, we're looking for the x value, so you're correct. The answer would be 0. Okay, so again, right here is the only point where the two graphs touch. So we state the x coordinate of that point, which is x equals 0. Okay, and just to verify, because we know sometimes the graph is unclear, sometimes it's not at a whole number, we also know how to solve this algebraically, right? So f of x is given as this function, so we replace it with its value, and same thing with g of x. Right, so we want to know where these two are equal. Okay, so the radicals are already by themselves. There's nothing in front, there's nothing behind. So we can go ahead and do the exponent right away. Right. Luckily, in this problem, both radicals get canceled out at the same time. Okay. Since we have x terms on both sides, we want to get them all on one side. So let's take away x from both sides. And then now to get the x by itself, we need to undo the plus 1. So we'll subtract 1 from both sides. Okay, so algebraically, we were solving the exact same problem. So it's good that we get the exact same answer. Okay, but like always, for equations, you can check your answer by substituting back into the original problem. Okay, so plug in 0 for all x's. Okay, and the two sides are equal, so that confirms that x equals 0 is the right answer. Okay. All right, so again, this warm-up was about square root functions, but don't forget we also have cube root functions that we covered in the 3.3 lesson, so make sure you review those. Okay, so today we're going to see a couple other types of radical equations that we didn't see last time. Okay, so why don't we start with, let's jump down to letter F. Okay, so square root of x minus 4 plus 6 is equal to x. Okay, so the general strategy we learned last class is, right, you want to get the radical by itself before you do the exponent. So we don't want to square both sides right away. Instead, the better idea is get rid of this plus 6 on the outside of the radical first. Correct. We would want to subtract 6 from both sides, leaving us with square root of x minus 4 on the left, and then equals x minus 6 on the right. Okay, so now that the radical is by itself, meaning nothing in front, nothing behind, just a reminder, we can't undo the minus 4 right now because it's inside the radical. Okay, so now the next step would be to square both sides because it's a square root. So the inverse would be to do an exponent of 2. On the left side, the radical and the squared cancel out, just leaving the x minus 4 behind. But the right side was not in a radical. So that means the exponent actually does something. Okay, so we know that x minus 6 parentheses squared means x minus 6 times the second x minus 6. Okay, so we would distribute this out. Okay, so we see the right side simplifies to x squared minus 12x plus 36. Okay, so from here, there's no more radicals, which is good, but we have a lot of x terms. And unlike the previous problem, we have an exponent. We have x squared. Okay, so this is a quadratic then. This is something we can either solve by factoring or completing the square or the quadratic formula. Okay, so let's try factoring. In order to factor, we need one side to be 0. So let's subtract x from both sides, and let's also add 4 to both sides of the equal sign. Okay, so I've noticed a lot of students lose the equal sign. They just write over here because all of this goes away. But actually, you need to keep the 0 equals because it's still an equation. Okay, so now that one side of the equation is 0, that means we can either do factoring or the quadratic formula. Remember, the quadratic formula always works, but if factoring is possible, it's faster. So let's try factoring. Okay, we know that first spot times first spot has to equal the x squared, so that would be x times x. The constant is positive, so the two signs match, but the middle term is negative, so it has to be two minus signs. It can't be two plus signs because then the middle term would have to be a plus. Okay, and then now we want to think of two numbers that multiply to 40. So it's going to be 5 and 8, right? Because you have negative 8x minus another 5x combines to negative 13x. Right. Yeah, so yeah, now that we factored it by the zero product property, when two things multiply to equal 0, either the first thing is 0 by itself or the second thing is 0 by itself. Okay, so our first potential answer is x equals positive 5. Our second potential answer, x equals positive 8. Okay, so we're not done yet, but let me see if there's any questions on what we've done so far to get to this point. We'll get to that later. Right now, let's focus on this problem. Okay. So now let's check our answers. Let's start by checking positive 5. Okay, so remember, when you check, you substitute into all x's. Okay, and then you simplify both sides and see if the two sides are equal. 5 minus 4 is 1. Keep everything else. Square root of 1 is regular 1. 1 plus 6 is 7, which is not equal to 5. Okay, so that means that the x equals 5 answer, yeah, is called an extraneous solution. Okay, and then now let's check x equals positive 8. So again, substitute your answer in for all x's in the original problem. Square root, you do the inside. 8 minus 4 is 4. Square root of 4 is 2. 2 plus 6 is 8. Okay, so that means that the actual answer is x equals 8. X equals 5 is an extraneous solution. Okay. All right, so let's go ahead and turn to the back. Okay, so another type of problem that we haven't seen before, let's look at letter G. So this one has 3 separate radical terms, right? 1, 2, 3. So one of the sides has to have 2 radicals, right? Even if we like move this over, it's not going to combine. So one of the sides has 2 radicals. There's no way around it. Okay, well, let's go ahead and square both sides. So the left side, very conveniently, because it's a single square root, the square root and the squared cancel each other out, just leaving the x minus 2 behind. Okay, now, yeah, on this side, very unfortunately, you are not allowed to square the two numbers separately. Okay, so just to prove it to you, let's say that we had something like 5 plus 3 parentheses squared. So the common mistake, yeah, yeah, the incorrect thing to do would be to try to do this, to square them separately, right? Because we know that the correct answer is 5 plus 3 is 8, and 8 squared is actually 64, right? So you see, when you square the two parts separately, you get a completely wrong answer. Well, well, we have to distribute out the multiplication. Okay, so to simplify this, I'll do it off to the side. The squared applies to the entire parentheses. So we want to write the entire parentheses twice. Yeah, so from here you distribute. You either draw like the arches or you draw this box. Some way of making sure that you do all 4 multiplications. Okay, so square root 3 times square root 3, that's regular 3. Square root 3 times square root x. You multiply the insides. 3 times x is 3x. Moving on, square root x times square root 3. Again, multiplying the insides. X times 3 is 3x. And at the end, square root x times square root x would be regular x. Okay, now we can combine these middle two terms. They are, both plus invisible 1 radical 3x. So we can combine those to, 2 radical 3x. So again, there's 2 of these terms from earlier. You can imagine invisible ones if you want. So just like how x plus x would be 2x, radical 3x plus another radical 3x combines to 2 radical 3x. Okay, so over on the right side, we now know that this is equal to 3 plus 2 radical 3x plus x. Okay, so yeah, if you try to square the two pieces separately, you miss the middle term. So yeah, very common mistake. So please be aware of that. Okay, so what do we do from here? We still have a radical term, right? In the previous problems, after we did the exponent, the radical was always it always went away, but we still have a radical. Okay, so we want to get the new radical by itself. Okay, so let's start by getting rid of the positive 3 here, right? We can subtract 3 from both sides of the equal sign. And we can also get rid of the plus x by subtracting x from both sides of the equal sign. Okay, so x minus x goes away, -2 minus another 3 gets you to -5. Correct?
Divided by 2 and 10.
Yeah, okay, good idea. So Beckett said, let's get rid of the 2 by dividing by 2 because we want to get the radical by itself. Okay, and then now the radical is isolated, right? Nothing in front of it, nothing behind it. So now we do another exponent. It's still a square root, so we're still gonna do a exponent of 2 on both sides. Say it again.
Sorry.
Oh yeah, these numbers do feel familiar.
There's a problem that has those numbers.
You're right. You're right. Okay, well let's see what happens though. So -5 squared, negative times negative is positive, and make sure you square both the numerator and the denominator. Okay, so the x is almost by itself, but it still has that 3 in front as a coefficient. Yeah, so we can divide both sides by 3. Yeah, so to do this calculation, instead of writing it as a fraction within a fraction, we can write it sideways as fraction division. Okay, so yeah, correct.
There's a problem with that exact answer.
You're right. Okay, so now we want to check if this is correct, but it's going to be really tough to check our answers because we have to do like square root of a fraction and the numbers are not perfect squares. Okay, so here is where I would recommend using a calculator to check your answer. So let me show you how I would do that. Okay, so again, what we're checking, let me write down this first. Right, we want to plug our potential answer in for all x's. So the left side becomes 25/12 minus 2, all in the square root. The right side is radical 3 plus radical x, which again, I think is 25/12. Again, normally what we do is we just simplify this and then see if it matches this side. But it's going to be really tough to compare these separate radicals. Okay, so my suggestion is going to be use your calculator to get a decimal approximation for the left side. Okay, so I'm going to type into my calculator square root of the fraction 25/12 minus 2. Okay, so let's see what that looks like. Okay, 1 second. It's rather laggy. Okay, square root of the fraction 25/12 minus 2. Okay, so the left side is approximately 0.289. Okay, so let's remember that number. Okay, and then now I'll type the right side into my calculator. Okay, so radical 3 plus radical 25/12. Okay, so right, radical 3, close that parentheses, and then plus another radical, radical 25/12. Okay, so it is not the same number, right? 3.18 or so.
Wasn't there, like, did you, did you do it for the division thing?
What division thing?
The symbol when they put 25/12.
Oh, for the fraction bar. Yeah. Instead of yeah, so yeah, instead of typing 25 divided by 12, it's the same thing, right? Same answer, but you can do this little mixed number looking thing to do a fraction bar. So this also represents the fraction 25/12.
Didn't know that.
Yeah, it can be useful. Okay, but yeah, we see the numbers are not equal. So that means that this answer is not correct. Yeah, so this answer is actually extraneous then. And that was our only answer. So yeah, there's no real solution. Yeah, this problem did have many steps. That's just how some of them are. Okay, so again, with radical equations, checking is always recommended for all types of problems. But yeah, with radicals, even if you do everything perfectly to get to your answer, it might be extraneous. Okay, so again, you have to check it. There's really no other option. Okay, so uh, let me jump down and look at letter J now. Okay, so here, instead of three radical terms, like in letter G, we only have two radical terms. Okay, but we still are going to have a little bit of a trickier time when distributing. So instead of leaving the two radical terms both on the same side of the equal sign, it'll simplify it a little bit nicer if we split them up. Okay, so let's start by adding the square root of x minus 2 to both sides. Okay, so you'll still have square root of 2x plus 3 on the left, but now the right side is 2 plus square root x minus 2. Okay, so there's no way to get this radical by itself, right? If you move this 2 over, then now this one's not by itself, right? So one of the radicals will never be by itself. There's just no way around it. Okay, so let's go ahead and try doing our exponent on both sides. Okay, so again, the side where the radical is by itself, that one will simplify nicely because the square root and the squared cancel out, leaving just the inside behind. Okay, so let's actually give everyone the opportunity to try to correctly simplify the right side. Okay, so go and take a minute or so on your own. See if you can correctly simplify parentheses 2 plus square root x minus 2, all squared. Okay, so the correct way to distribute out the right side is, again, to recognize that the exponent applies to the entire thing. So you want to write the parentheses twice. Okay, so 2 times 2 is 4. 2 times radical x minus 2, the 2 just goes in front. Over here, radical x minus 2 times 2, again, the 2 goes in front. And then at the end, radical x minus 2 times radical x minus 2. Again, the square root times itself cancels out to the inside. Okay, so there's a couple things that can be combined. These two radicals, right, they both have the same index and radicand. So you are able to combine together the coefficients. 2 plus another 2 is now 4. But then, yes, we can also combine the regular 4 and the minus 2 at the end, right? 4 minus 2 is positive 2. But then don't forget, we also have this x that's on the outside. Okay, so yeah, you may have put these in a slightly different order, but it should be 2 plus 4 square root x minus 2, and then plus x. Okay, so we've made some progress, right? We started with 2 radicals. Now we're down to 1 radical. But since we still have a radical, we need to get the new radical by itself. Okay, so we want to subtract 2 from both sides, subtract x from both sides. Okay. Okay, so now the 4 that's multiplying the square root of x minus 2 needs to be divided away. Okay, yeah, now the radical is by itself, nothing in front, nothing behind. So now we're able to do an exponent of 2 on both sides. Here, the left side nicely simplifies because the square root and the squared cancel out. The right side, there's no radical, so the squared actually squares everything. Okay, so the denominator, 4 times itself, is 16. But just like before, we need to distribute when we square, right? So x plus 1 squared is really x plus 1 times another x plus 1. Okay, so the numerator distributes out to x squared plus 2x plus 1.
All that over 16.
Yep.
What the?
Okay, so yeah, it's actually not that complicated once we get rid of the denominator. Right, things look very complicated as fractions, but if we can make it not fractions, that'd be better. Yeah, so let's go ahead and multiply both sides of the equation by 16. Okay, so the good thing on the left side is the 16 gets used up when it cancels out the denominator, right? So you do not distribute the 16 to the numerator. The numerator stays the same. But on the other side, because there's no denominator, the 16 does multiply in. So 16 times x is 16x. 16 times negative 2 is negative 32. Okay, so again, we're making real progress. There's no more radicals and there's no more fractions. But we do have a quadratic, right? So we want to move everything to the same side so that we can get a 0. So let's subtract 16x from both sides and then also add 32 to both sides. Okay, so x squared minus 14x plus 33 equals 0. Yeah, sorry. Okay, so this one, again, you can always use the quadratic formula, but this one may be factorable. Okay, I'm going to suggest x minus 11, x minus 3. Let's verify. Yeah, good. Yeah, x squared minus 3x minus 11x plus 33. So 11x, negative 11x minus 3x does combine to negative 14x.
I'm gonna plug that in phrase.
Correct. You set each one equal to 0 first to get your potential answers. Okay. Yeah, and we want to check both answers to see if they work or if maybe there's any extraneous solutions. Okay, so first I'll check 11. Again, you can use your calculator for this if you want. You can type the whole left side into your calculator and see if it equals 2. Question?
It by the exponent first and before moving it side by side because I did that and got the same exact answer without doing it.
You got both of these numbers? Okay, so let's see if 11 is actually an answer. Okay, so 2 times 11 is 22, plus 3. 11 minus 2 is 9. 22 plus 3 is 25.
5 minus 3 is
Yeah.
2. So 11.
Yeah, so it looks like 11 actually is an answer. So yeah, you could square both sides away, Emily, but I'll show you the correct way to do it. But let me finish up the check first. So now we're checking positive 3. Uh, 2 times 3 is 6, plus 3 is 9. 3 minus 1 is, sorry, 3 minus 2 is 1. Square root of 9 is 3. Square root of 1 is 1. 3 minus 1 is 2. Yeah, so there's not always an extraneous solution. It is possible to have 2 correct answers. Yeah.
There's some where both could be extraneous.
That is correct. Okay, so going back. Yeah, so going back to the beginning, the suggestion was, well, can you square both sides right away without moving one over? The answer is yes, but just like how when you square x plus 1 squared, it's not just x squared plus 1. You have to write it twice and find that middle term. It would be the exact same thing here. To square this, you would have to do... Yeah, you have to do the parentheses twice, and then you'd have to distribute it out. This is going to get very complicated because you got to multiply the insides. Yeah. Minus 4x plus 3x minus x. And then this one would be the same. And then the last one would be, it would cancel out at least. And that all equals 4. So you could continue from here, but I don't suggest it. Emily, do you see how the first step you would have to distribute? You can't square the two. You can't get rid of both radicals by squaring because you create this new radical in the middle. Okay. So yeah, those are the new types of equations that we didn't see last time. There are some problems, based on last class's type as well. But there's also these new ones. Okay, so I'm gonna give you guys a good amount of time to practice. You can go back to the front and do the problems we skipped. But yeah, all of these types of equations could show up. Okay, so please let me know if you have any questions as you're working.